All right. Well, welcome everybody. A couple of things before we get started. We're going to have a demo in here, so if you want to maximize your screen, it'll make it easier to see. And the other thing is, if you have any questions, feel free to put them in the chat, and I'll be happy to answer it at the end of the presentation. All right. Let's talk about Kubernetes, shall we? One of the things my wife and I like to do when we are not in COVID is go to a good restaurant or a bar for a good meal. And that's for two reasons. The first one is that way we don't have to fight about who's going to do the dishes afterwards. And the second one is that as customers, all we have to do is place an order. So in this case, it's pizza, pasta, and 2 drinks. You can tell I like Italian food. And we take that order and give it to the waitstaff, and they take it to the kitchen, give it to the chef, who schedules it with the sous chefs, who actually do the work and prepare our meal. And eventually the meal comes to us. We don't have to worry about what kind of kitchen they use, what kind of utensils, what kind of knife, etc., etc. Wouldn't it be great if we could do the same thing with an application? And that's exactly what Kubernetes tries to do. Kubernetes allows developers to just create a YAML manifest, which basically says what they want to instantiate. So what type of applications they want to run. And then that manifest is passed to an API, an HTTP API, which sends it to the cluster where we have main nodes running. And those main nodes will then schedule your application within one of the child nodes, or multiple if necessary. And you don't have to tell it which node to install it on or how to install it. It just installs it and runs it, which is fantastic. You don't have to do a lot of the work manually anymore. But what's at the heart of Kubernetes? At the heart of Kubernetes, you have images and containers. Because images are a full copy of your code with all the dependencies. And they all get packaged in a way that can be installed anywhere, that there's a runtime for containers. And then we create an instance of that container and we make it run in Kubernetes. And Kubernetes is in charge of managing the container lifecycle automatically. It will create containers to run our application. It will stop them. It will restart them if they fail. And it does that automatically without you having to think about it. But how do you move from just your code all the way to Kubernetes? Well, you start with your app code. Then you put it in a container which is in charge of executing your code. Then we send it to Kubernetes, and within Kubernetes, we have a wrapping for your container that's named a pod. And that pod is in charge of running your container, which is in charge in turn to run your code. Then that's wrapped inside of a replica set, which is in charge of scaling, making sure that you have the correct number of instances running, and making sure that your application is running in a way that's healthy. And finally, that's in turn wrapped into a deployment, which is in charge of running any updates and rollbacks to your code. Deployments are where the magic happens. And yes, you can run pods by themselves or a replica set by itself, but really what you really, which you really want to interact with are deployments. All right, but beyond your application, there's other things that we need to create. We also need to create services that will dictate what ports are open to your application and in which IP they're listening to. We also need config maps. And config maps allow us to create the environment variables and the configuration files that your application needs to run. You also have secrets where you can store sensitive data, which in Kubernetes, that's 64-bit encoded rather than encrypted. So keep that in mind. And there's many more types of resources that you can create. But any resource you create in Kubernetes will be in the way of YAML manifests, which are basically text files. But if we wanted to get started with Kubernetes today, what would we need to do? Well, we could start in our local machine. And in fact, we're going to see a demo in a second where we're going to be running Kubernetes inside of Minikube. And there's another set of options that also just as good. We also have cloud providers that will have free trials and also free playgrounds. When I was starting with Kubernetes, I started with Katacoda. They have good tutorials and environments set up there. But we mentioned YAML and manifest before, right? So what do they look like? Well, this is the basic anatomy of one at the very high level. You start with an API version, so the version of the API we're trying to hit, the kind of resource we're trying to create with this particular manifest, which could be a service or a pod or a deployment. Then we give it some metadata, and in particular, we give it some annotations. And the annotations are human readable information that allows us to put stuff like the version of the file that we're using or who created this file, for example. Then we have labels that are used by Kubernetes to determine which files or which manifests work together. So for example, which service opens a port for which deployment. And we'll see some of that in a second in our demo. Then we'll have a name for our resource that we're creating. And finally, depending on whether you're creating a deployment or a pod, or whether you're creating a config map, you will have either a spec or some data. So a spec will, for example, for a pod will be what our container looks like. For data, we'll have the information for your secret, for example. And that's the basic anatomy of a YAML manifest. But enough of that. Let's see what our first command for Kubernetes would be. So we will start with kubectl. That's the main command for Kubernetes. Then we're going to tell it that we're going to create a pod using the run command. We're going to give it a name. We're going to tell it what image to run. And it will pull an image from Docker Hub, unless you tell it another repository. And you can think of Docker Hub as GitHub, but for containers. Finally, we get to tell it what port our image is going to be listening in. And if we stop at that particular point in time and run that, Kubernetes will create a manifest in memory and run it. And it will have a MariaDB running in Kubernetes in a pod. But I don't like running just commands like this. I like doing everything as code. So I'm going to add a couple of items to our command. And the first one is going to say, do not run this on the server just yet. And instead, just create the YAML and output it to the terminal. And what does this give us? Well, it gives us our first pod. And this is what the manifest looks like for a pod. We see the same metadata we discussed before. And underneath, we have the spec for our container. That's going to be running inside the pod. We see it's going to be running a MariaDB image. And it's going to be listening on port 3306. And that's the basics of it. And this is a partial result of the execution of that command. That's the most important part. But let's create something a little bit more interesting. Let's create a deployment, since that's what we're going to be interacting with most of the time. And it's basically the same command, except that it says create deployment instead of just run. That everything else is the same. And that creates something that's a little bit more complicated, but we can break it down pretty easily. At the very bottom, we have the specification of our container running inside of a pod. Then we have our replica set, which is going to be running one replica in this case. And finally, we have the definition of our deployment. And that, all those three things is what make up our first deployment. One thing I should mention is notice how they all say MariaDB here. That's because that is the labels that is using to match the replica set to the deployment, and more importantly, to services that we'll see in the future in our demo. But that's basically our first deployment. But enough of that. Let's take a look at a demo. And in this demo, we're going to go all the way from taking an application that's living on my laptop right now to deployments in Kubernetes, and we're going to do everything as code. Okay. So what is our demo going to look like? Well, we're going to start with our application, which we're going to run in Docker. Then we're going to write some YAML manifests. We're going to push that to Kubernetes. That's going to be running in Minikube in my machine. We are going to have, after that, a couple of more advanced topics. We'll talk about sidecars and what they are. And then how to create manifests so we don't have to make copies and maintain multiple versions for different environments. All right, so let's take a look at that. All right, so what will our application look like? Our application first will have 3 pages. The first page of our web app will be just a node page that will just welcome us to the conference. The second one will pull data from MariaDB and display it on the screen. And the third one will pull the same data from MariaDB, but it will cache it using Redis. All right, so that will be our application. And we'll see it in a minute. But we're going to run this using Docker. In order to do that, we're going to have to create a couple of things. First, we're going to have to create a Docker file. And the Docker file basically just has a series of commands that are going to copy our code into a container or an image, I should say. And then it's going to have all the information on how to run it using NPM. And then once we build that, we're going to run it using Docker Compose. And I really enjoy using Docker Compose because it fully defines what our application has to look like. So it's going to build our node application. It's going to pull the images for Redis and MariaDB from Docker Hub. Those are the official images. We're going to define some environment variables so that they can all talk to each other. We're going to have some volumes to store the data from MariaDB. And we're going to have a network that's going to allow these 3 things to talk to each other securely. And I can check this file in and keep track of it. But let's see that actually in action. All right. So here is our node application. And we can see inside of that file, of that folder, we have our Docker file. And on the root of our project, we have our Docker Compose file. And that Docker Compose file is what we see here on the right. And we see that our Docker Compose file will have 3 services. The first service will be all about MariaDB. And it tells us that it's pulling the official MariaDB image. We're going to give it a file that has some environment variables. We're going to give it a volume that's going to map a drive from my machine to the container when it's running, where we can save the data on the first volume. And the second volume is actually going to allow us to run this file automatically into MariaDB when it starts. That will create data for our demo. And it's just a list of foods. I really like food. All right, so let's see all this in action. In order to run the application with Docker Compose, the only thing we need to do is Docker Compose up, and that will bring the application up. And we can see that's first created a network for our containers to run, then it's creating our containers themselves. And I can come in here, and I can say localhost 3000, and that will bring our application up once the containers finish getting created. So let's give it a second, make sure that it's finished. Let's hit that. It's not quite ready quite yet, but we give it 1 more second. Starting to come up. And we have it here. And we see have our first home page. We have our foods page, which is showing the data that we're pulling from MariaDB. And then we have our Redis caching, which is originally pushing from MariaDB. And I think I put cache for 5 seconds before it goes back and pulls from MariaDB again. Excellent. So now we have our application running in Docker. Excellent. So now let's bring it all down so we can see the next step in our demo. So I'm just going to say Docker compose down, and that will bring everything down. And this is a great way to do development. Excellent. So everything is coming down. I am going to empty the cache so we can see that everything came down. And I should mention at this point that I've already pre-compiled our application, the Node application, and I pushed it to Docker Hub, which is where we're going to pull it from in Kubernetes. All right. Now, the last thing I will mention before we move on is that beyond MariaDB, in our Docker Compose file, we also have a section for our Node application, which is actually building the Docker file that's inside of our Node app. It's also pulling some environment variables from a file, and it's listening on port 3000. And finally, we have our Redis image at the bottom. So all those three, all the pieces of our application are defined in this one file. Excellent. Well, let's go back here, and we can see this is what we built. All right, so we just ran our application in Docker Compose. Now let's see how we can do the same thing for Kubernetes. And we can see that while we've defined everything in Docker Compose so we can run it in Docker, inside this Docker file, we can do the same thing with manifests for Kubernetes. So we're going to create deployments that will contain our images running in pods. Then we're going to have services that are going to define which ports we're listening on. And it's going to route the information to our pods. Then we're going to have a volume so we can save data from our database. And then we'll have some config maps where we'll have some environment variables to configure our different databases and applications. Right? But if I wanted to create all those 11, I think there were 11 files manually, I would probably feel like this guy here. So let's not do that. Instead, let's generate our files using Compose. And all it is we take our Docker Compose file. It will use some magic pixie dust, and it will spit out all the manifests for us. And out of the box, that gets us 90% of the way there. And then you always usually want to customize them a bit. But let's see how we can do that. All right, I'm coming here, and I'm going to run a few commands that are pre-typed so that we're not in typo land. First thing I'm going to do is I'm going to make a new directory, and I'm going to cd into it. And then I'm going to run compose. And the command for running compose is very simple. It's just compose the path to our Docker Compose file and convert. And that creates all the files for us. Let me clear this so we can make this a little bit cleaner. And we see it's created a whole bunch of manifests for us. But as I said, you always want to customize them a little bit. And I have done just that for our presentation. So let me do a good old cooking show trick. And I'm going to take the pie out of the oven as soon as I put it in. And we're going to use some files I've pre-created. So we're going to take a look at those. Kubernetes with Redis. And we can see it's basically the same thing that the Compose had created. I just customized it a little bit. All right, but let's take a look at those guys. I'm gonna come up here, and we have a directory with all those files listed. And if we see with what the files versus what we said we were going to create, we can see we have our 3 Redis deployment files, or manifest, I should say, our 3 node manifest files, and our 5 MariaDB manifests. So we have all we need to run our application in Kubernetes. And let's take a look at some of them, shall we? And this is our deployment for our node application. And the name of the deployment is going to be node with DB. And we have some labels that identify that fact both at the deployment level and the replica set level. And we can see that we have one replica, so we're going to be running one instance of our application. And if we keep going down, and I'm not going to go line by line because there's too many things, but we can see at the bottom we have our spec for our container. And we can see at the bottom that we have, this is going to pull the Bolbec image that I pre-created. So it's going to pull this image from Docker Hub. It's going to be listening on port 3000. And additionally, we have some environment variables that I have created. So for example, DB host. So this will tell us where MariaDB is listening. And the value for that is going to come from a config map. So let's take a look at what a config map looks like. So let's take a look at that. And we can see that in the config map, we have a section for data, including our DB host. Now, don't do this at home. Do not put passwords in plain text on a config map. Use secrets or something, or a third-party application. All right, now let's take a look at our service. So this is a service for our node application, and therefore it defines what port is going to be open for our application in the cluster. And we can see here that we're going to be opening port 3000. More importantly, we can see once again that we have the same label. And that's how we know that this particular service is going to be working with our deployment for a node application. If I look, on the other hand, at the service for our Redis application or Redis database, you can see that there's a different label, and that will be listening in a different port. All right, and if we look at the deployment, we can see that that's the same label for our deployment that's hosting our Redis container. Excellent. So let's see how that works and how we can put all these guys in Kubernetes. And we have also the MariaDB files, but they're very similar to the other ones. So we're just going to move on. The first thing I'm going to do to apply the manifest to Kubernetes and have our application running is I'm going to pull up the Minikube dashboard. And this is just so that we can see what's going on inside of Kubernetes as we run our files. We can see at the very beginning that the only thing running is the service for Kubernetes. So our API is the only thing running in Kubernetes right now. The next step is going to be applying each one of these manifests. And the way you do that is you say kubectl apply, and you give the name of the manifest that you want to run. Or you can give kubectl apply and the name of the folder where you have multiple manifests, which is what we are going to do. Well, let me clear the screen here for a sec. And we're going to run kubectl apply. And we can see immediately all those manifests start to get created. And we can see in Kubernetes, all those files are starting to be instantiated. So we can see that we're starting to have all the 3 deployments for our application and our databases. You can see our 3 pods. We can see our replica sets and our services, among other things. Excellent. So all of that has just been created. Fantastic. All right, so how do we access it? Well, in order to access it, we're going to run a command minikube called minikube service list, because minikube is going to assign its own IP address to our application and to each one of our services. And we can see that IP address right here. And I could copy and paste that IP address into our browser, and that would give us, that would open our application. But instead, I'm going to do something that's easier. I'm just going to say minikube service list, and I'm going to give it the name of our service. And that brings our application up. And we can see that we have MariaDB running, and we have Redis running. So with that one command, we have managed to create one application and 2 databases in Kubernetes. Isn't that fantastic? I think it's just great. But let's pretend that your application is the next Facebook, and one instance of your application is no longer enough to handle the traffic. So you need a second one. Normally, that would mean that you would have to install new software, start your application, maybe a new server. In the Kubernetes world, all you have to do is say kubectl scale what you want to scale up or down. In this case, it's our deployment for our node application, and the number of replicas. So in this case, I'm going to say that we want 2 replicas. And if I come back to our dashboard, you'll see that immediately, and I don't know if you saw it change, it was really quickly, we have a second node application running. So if I come in here and still refresh our application, actually, let me go to the front page. You can see the name of the host that's running our application here. And let me try bringing up the second instance. Let me try bringing Chrome. I'm going to paste the IP address. Let's see, that's still the same one. So let me try open a few windows so that it will actually get us the other version, because it's actually it's smart about what's being used and what's not. So sometimes it takes a few tries, but if not, we're not lucky. One last try, otherwise we'll try it again later. Oh, there we go, finally. And what we can see here is that we have the second instance. So that's running on host that ends on KS8S, and this one is running on J4QXF. So we have 2 instances of our application running. And it only took was that one command. I didn't have to install anything. Fantastic. All right. So that's, now let's move on to the next step in our presentation. So let me bring everything down. So in order to uninstall everything from Kubernetes, the easiest way to do it is by running a new command called kubectl delete, and we're going to give it the name of our directory where all our manifests are. And if I come up here, you can see that immediately everything starts to come down. And just like that, we deleted our application from Kubernetes. Excellent. So let's see where we are. So this is a high-level version of what we've done. So we have our application running, 1 container per pod, which is what you want 90% of the time. We've established network communication within the cluster for all the pods. It's as accessible via our browser. And we can know how to scale it up and down, which is great. And it's what we want most of the time. So we have Node with the caching layer and MariaDB. But what if our network is problematic? And that's why we want to have a caching layer, so that we can not have to do so many network calls. In that case, is that the right place for our Redis cache? Can we put it closer to our node application? That brings us to our next step, which are sidecar deployments. And sidecar refers to the fact that we can put a second container that provides additional functionality to the main container within the same pod. And you don't do this very often, but when you do it, when you need to have something treated as a local resource in the same pod. Once you put it in here, you can talk to each other as local hosts, and you can use the same volumes for data. The big disadvantage here is that you can no longer manage these containers individually. You can no longer individually scale, for example, the node application up without scaling the Redis application as well. But that's okay. For our case, is exactly what we want to do. So let's see how we can do that. All right, I'm going to come here. I'm going to have a new set of files. And it's basically the exact same files as before, except that now I have deleted our Redis deployment and I have deleted our Redis service because I want to put them in the same pod. So if I don't have deployment, how can I deploy to Kubernetes? Well, let's take a look at our deployment for a node application. And if we go down inside of our pod definition, we still see our node application being deployed. But if we keep going down, now we have a new section for our Redis image. All right. And that's how we can put two containers within the same pod. So let's see that in action. I'm gonna come in here, let me clear this. And then we're gonna run a couple of commands. The same command that we had run before, so kubectl apply. But I'm gonna give it the other directory, so our new directory with our new set of files. And once again, we see everything started to get created. But now, if we notice, we only have 2 deployments instead of 3. Same thing with our pods. We have 2 pods instead of the 3 that we used to have before. That's because we're no longer creating a separate pod for a Redis container. Instead, if we open the pod for our node application and we go down, we're going to see a section for containers that lists which containers are running within that pod. And we can see that now, in fact, we have 2 containers within our node application deployment pod, which is exactly what we wanted. So let's run that now. So I'm going to do or access that. So I'm going to do again minikube service and the name of our deployment. And we can see we have our regular page, our foods page, and something is going on with our Redis page. Data is not coming up. So let's learn how to debug a deployment. So I'm going to come here and I'm going to run a few commands to figure out what's going on. So the first one I'm going to run is kubectl get pods. And that command, which could be kubectl get deployments or kubectl get services or anything really, gives us information about what's running of that particular resource type. So in this case, we see that we have two pods running. And it looks like they're running, so there's nothing wrong with the pods themselves. So let's see if there was something wrong during deployment by running another command called kubectl describe pod, and I'm going to give it the name of the internal name of our pod, which is what we have right here. And I run, and that gives us a lot of the information of everything Kubernetes knows about our pod. But what we care about is right here at the bottom. That is information about our deployment and creation of our pods. And we can see it created our images successfully, it created the containers, it started them. So everything looks good there. So let's go and take a look at the logs in our pod for our application. So I'm going to once again go get kubectl get pods because I'm going to need the name of the pod one more time. And then I'm going to go do kubectl logs, and that will give us the logs of our application. Now I'm going to give it the logs. I need to tell it what I want the logs of. And the first thing I'm going to give it is the name of our, the name of our node application or our node pod. So I'm going to copy this guy. But because I have 2 containers running within the same pod, I also have to give it the name of the container. And we can see that inside of our container, our application is throwing an error Redis connection. And we see that it's trying to connect to a Redis service that's listening on 6379. But we destroyed that service, we deleted it. So how do we connect? Well, let's go take a look at our environment variables that tells us how our application is connecting to the databases. And we can see down here that we're connecting through our service called Redis. But we deleted that, so let's get rid of that. And instead, because they're running in the same pod, I'm going to connect to it through localhost. All right, so let's come here and let's try it again. So I'm going to run a new command, two commands, in fact. And I will tell you what they are in a second after I run them. The first command is basically kubectl apply, and we're applying just that one file that we changed instead of starting everything. And the second command is kubectl rollout restart, which basically says, go ahead and restart my deployment for my application. And the reason I have to do this is because when I built my application, I didn't tell it, check for changes in the environment variables. So I have to physically restart my application. But instead of logging into each one of those servers individually, I just let Kubernetes restart them all, which is great if you have multiple instances running. All right, it looks like it's done restarting. So I'm gonna once again come in here and say minikube service. I'm gonna bring up our application again. Our first page, our second page, and now Redis is coming up. Fantastic, so now we know how to debug a deployment. Excellent. So let's see where we are in our demo. Well, we've done sidecar deployments. Now let's take a look at multi-environment manifests. Because one of the things that really annoys me is having to have multiple copies of files that only have one or two differences depending on which environment you're running. So let's not do that, and instead use another tool. This is a tool called Customize. And Customize basically takes an original YAML file, you give it a customization file, and even a partial deployment file, and it will merge them all into one final generated YAML. And that's what we can deploy to our application. So let's see how that works. All right, so I have another set of files here. Okay. And for this demo, we're just going to use our deployment just for simplicity. We could put all the files here, but for our simplicity, we're just going to use that one. And this is our node application with running one replica, and it has two annotations and one label. I also have a customization file. And it's type customization. And it's going to use as a resource, or the file that it's going to be applying to is going to be our node application deployment. It's going to have a common label. So it's going to add a label to our file. And it's going to use a new annotation as well and add it to that file. But we're not going to stop there. I also want to create a test file for our test environment. So I'm going to have a different customization file, kind customization. Once again, it's going to have a new environment variable label that's going to say test. And more importantly, we're going to have a patch or a partial deployment file that's going to change the number of replicas that we want to run in test. So in test, I want to have 2 replicas running from the get-go. All right. And how do we do this? What happens when we run all this through Customize? Well, let's take a look. I'm going to run a couple of commands. Once again, the first command, we're going to create a new directory called temp. And the other command basically is kubectl customize. Then I give it the path to the directory where our customized files are. And then I'm giving it a path to save to a file. The same thing with the other. And that will create some files for us with the customized YAML. And if I come here and we look at the externally created files, which Goland is nice to tell us about. I'm gonna come here and I'm gonna extend this. We can see our new files, and we can see it's the same deployment file that we had before, but now we have a new set of labels and annotations. But we still have the one replica. Now, if we look at our test file, we can see that we have a different label. So this is our test file, and it has a second replica. So this will run as 2 replicas of our application, or 2 instances, when we run the file. And that's how you create, and it makes it easier to maintain manifests in Kubernetes using Kustomize. So that's our demo. But we barely touched on all the stuff that Kubernetes can do. There's tons of other resources that you can use. And Kubernetes attaches to a very rich ecosystem. It's huge. There's new things coming up all the time. Everything from securing your application to deployments to network. There's a lot of things going on out there, and it's all going very fast currently. But at the end of the day, right, we've taken an open source tool like Kubernetes that's available on every cloud available out there. You can put on your machine, you can put on-prem, that integrates with a whole bunch of other applications and third-party services, which helps you simplify the way you maintain and deploy your applications, including very complex systems like microservices, where you don't have just 1 or 2 applications, but you have thousands. And we've done it in a way that's everything as code, so we can check it in and audit it. At the end of the day, Kubernetes takes care of the mundane so that we can set our imagination free. And at this point, I will take any questions.